Hello guys, I hope you're all fine. Today we are here to discuss about distribution system voltage regulation. So let's get into the topic. In distribution system, automatic voltage regulation is provided by using the following methods. The following methods are substation bus regulation, whereas the next one is feeder regulation, whereas the next one is supplementary regulation. Here the first one is substation bus regulation. Here the substation have a separate voltage regulator which is used to control the secondary side of bus voltage. In general, it will have three phase regulators, whereas the single phase regulators are also used when there is unbalanced phase voltages. Whereas the next one is feeder regulation. Here it is used to control the voltage of each feeder. There are two types of feeder regulations. The first one is induction voltage regulation. There are two types of windings in it. One is primary winding, the second one is regulating winding. Here primary winding wound on the rotor and connected across the line, which is parallel through the line. Whereas the next one is regulator winding. It is wound on the stator and connected in series with the line. Here the voltage induced in the regulating winding is added to the primary winding in order to get output voltage. Whereas here the output voltage can be varied by changing the position of the rotor. Here P means primary winding, R means regulating winding. This is the rotor, this is the stator. Whereas the next one is step voltage regulator, SVR. It is an auto transformer with taps or steps in series winding. Here, depending on the polarity, the voltage induced in series winding is either added or subtracted from the primary voltage. Here a reverse switch is used to change the polarity, this polarity, and also then the output voltage is varied by changing the tap position. Here this is the stepper series winding, whereas this is the primary winding, this is the bridge reactor, this is the RS means reverse switching. This is all about the step voltage regulator. And also now let's see about the applications of voltage regulators and capacitors. Here if you observe here, this diagram represents the applications of voltage regulators and capacitors. And also here this curve is there now, this graph. Here this is the curve 1. It contains only load only. Here in the x-axis there will be length along fader, whereas the y-axis is voltages. Here you have, if you observe here this curve, it contains only load. This is curve 2, this one is curve 2, whereas this one is curve 3, this one is curve 4. This is the maximum limit, this is the minimum limit, this is the maximum limit. Let's discuss about those curves. Here if you observe the curve 1, it shows the voltage profile only with the load along the line. If you observe here, if you observe this curve 1, there is only load. Whereas the curve 2 is, it shows the voltage profiles moved up by adding the voltage regulator R1. Whereas in the curve 2, the voltage regulator is added to the load. Whereas in curve 3, another capacitor is added to the load and R1, so that the voltage profile will raise to curve 3. Whereas in the case of curve 4, here the R2 is added. This is called a supplementary regulator. As this is added, the voltage profile will be raised to curve 4. This is what I told in this theory.